Swayam Prabha. Digital India. Educated India.
Welcome back, learners. The video is for the subject of Geography for the course of Bachelor's in Arts with Geography or Bachelor's in Arts with Honours in Geography. The video is for the paper of Climatology. Today we are going to start Lecture 7 of Module 3. The topic of the lecture is Jet Streams, Concepts, Classification and Significance. The video is being recorded by Dr. Pallavi Upreti. The course coordinator and presenter for the video is Dr. Pallavi Upreti, affiliated to Department of Geography, Doon University. The academic expert and reviewer for the video is Professor Santosh Verma, Head of the Department, Department of Geography, SDM Government Degree College, Doiwala, Dehradun, affiliated to Shri Dev Suman, Uttarakhand University. The video is produced and presented under the project name DTH Swayam Prabha Channels of MHRD, New Delhi, India. Hello learners, I am Dr. Pallavi Upreti, Assistant Professor in the Department of Geography in Dr. Nityanand Himalayan Research and Study Center, Doon University, Dehradun. Today in this particular video lecture, we will be discussing jet streams, the meaning of jet streams, the classification of jet streams, and the significance of jet streams in defining the global atmospheric conditions. So let's begin. In the due course of this video lecture, the learners will be able to understand the meaning of jet streams and various concepts which are associated with jet streams. Further, what are the factors for the formation of jet streams? What are the properties of jet streams? What are various types of jet streams and development cycle of jet streams in terms of index cycle? And finally, we'll be understanding how jet stream affect the weather conditions across globe and how the jet streams affect the aviation in different parts of the world. So let's begin. Jet streams are narrow bands of strong, rapidly moving circumpolar winds which blow from west to east in the upper levels of the atmosphere. So jet streams are very fast blowing winds which have circumpolar dimension. So they cover the entire globe, blowing from west to east in the upper atmospheric level, and these meandering air currents flow in a narrow belt of few hundred kilometers width in both the hemisphere, confined between the poles and 20-degree latitudes in both the hemisphere. So their extension is from polar areas to maximum 20-degree latitudes in both the hemispheres, and they primarily blow in the upper tropospheric region extending between 8 to 14 kilometers above the earth. So as you can see in the diagram, the upper limit of the troposphere is on an average 12 kilometers, and troposphere extends more over the equatorial areas and it is compressed near the polar areas. So these jet streams, they blow somewhere around the upper regions of the troposphere. We have discussed in the initial lectures that the upper limit of the troposphere is tropopause, which separates the stratosphere with the troposphere. And these jet streams blow in this particular boundary zone of the stratosphere and troposphere regions along the tropopause limit of the troposphere. So jet streams are some of the strongest winds in the atmosphere. Their speed usually ranges from 129 to 225 kilometers per hour, but at their maximum they can also reach to 443 kilometers per hour also. You can understand that they are very strong, rapidly moving winds which are found in the upper tropospheric regions, and they have circumpolar circulation path blowing from west to east. Now, jet streams meander around the globe, dipping and rising in altitude and latitude, splitting at times and forming eddies. and even disappearing altogether to appear somewhere else. So they are very, very dynamic in nature, with constantly forming a wavy pattern while circulating around the globe. The actual appearance of jet streams result from complex interaction between many variables, such as the location of high and low pressure systems on Earth's surface, existence of warm and cold air, and seasonal changes across the latitudes. The flow often shifts northward and southward following the apparent shift of the sun. So, as we know that different latitudes of the earth are heated up during different time periods. During the summer solstice, the sun is overhead the Tropic of Cancer, whereas during the winter solstice, the sun is overhead the Tropic of Capricorn. And in both these conditions, following the apparent northward and southward movement of the sun, the jet streams also shift northward and southward. They are faster and extensive in winters when the temperature differences between the tropical, temperate, and polar air currents are greatest, and they shrink back to their original regions during the summertime period in both the hemispheres. Jet streams are often indicated by a line on a weather map indicating the location of the strongest wind. However, the jet streams are wider and not as distinct as a single line, but they are actual regions where the wind speed increases towards a central core of greatest strength. So one way of visualizing this is consider it as a river. The river current is generally strongest in the center, with decreasing strength as one approaches towards the outer margins or river banks. Therefore, it is said that jet streams are actually rivers of air with variable velocity, where the velocity is maximum at the central core region and decreases towards the periphery, and they impact the weather conditions, air travel, and many other important atmospheric phenomena that takes place in our atmosphere. So they are very, very significant for defining the Earth's atmospheric system, and they are part of upper air circulation with distinctive impact on surface conditions, also on the wind movement, in defining the high and low pressure systems, and in regulating the precipitation regime also across the latitudes. A stunning visualization of jet stream is prepared from the accumulated data of NASA. And in this visualization, you can clearly see the travel path of jet stream, and you can see that they are rapidly traveling from west to east, and they are covering the entire globe. So they are very fast moving winds which are found in the upper tropospheric region, moving from west to east. Observe the deep meanders which are formed by the jet streams, which are extending from the polar areas to as low as 20-degree latitude towards the equatorial region. What causes jet streams? How are jet streams formed? Jet streams are generally the product of the uneven heating of Earth's surface. As the sun beams down on Earth, it warms certain lower latitudes more, particularly the tropical areas as compared to the polar areas. And as Earth is heated, it warms up more in the tropical areas as compared to the polar areas, and the warm air expands and becomes lighter than the surrounding air. As a result, it rises, creating a warm air current which ascends to the upper tropospheric regions near the tropical areas, and on the contrary, the polar areas receives less insolation and they remain cooler, due to which heavier air flow from the polar regions towards the lower latitudes near the Earth's surface, forming a cool current near the Earth's surface. So due to differential heating of different latitudes on the Earth's surface, there are differences in the temperature and pressure conditions, which leads to the formation of movement of winds on Earth's surface and air currents in the upper atmospheric region of the Earth's surface. And as a result, the jet streams result from the horizontal differences in temperature and pressure conditions that exist over a considerable vertical distance through the troposphere. And these temperature differences produce a horizontal pressure gradient that drives the geostrophic as well as the gradient winds, which finally defines the jet stream location, path, velocity in different regions of the world. The greater the horizontal temperature differences, the stronger the jet streams. Thus, the jet streams are air currents in the highest part of the atmosphere, usually blowing at the height of 8 to 14 kilometers above the Earth's surface, primarily in the tropospheric region, often following the boundaries between the hot and cold air along the latitudinal zones. So you have to understand this, that when Earth heats up, it does not only heat up the surface. As a product of heating of the Earth's surface, there are variations in the vertical dimensions of the troposphere also, where in the tropical areas, the troposphere is heated to a greater extent as compared to the polar areas where the temperature remains comparatively low. So these temperature variations along the vertical extent also creates the differences in pressure gradient, leading to the formation of rapidly moving streams of winds or air current in the upper tropospheric regions, which are called as jet streams. So different types of jet streams are observed over the latitudes. Few jet streams are found along the polar areas, while certain jet streams are located along the mid-latitudinal areas, which we will be discussing in a short while. So as you can see in this diagram, also the regions which receive more insolations develop low pressure conditions due to high temperature on the surface. And contrary to this, because these low pressure centers are regions of convergence at ground surface, and finally after the convergence the air ascends. Contrary to the convergence at ground surface, the low pressure center regions have divergence in the upper atmosphere. Besides this, if you have high pressure centers at the ground surface, which are created because of low temperature primarily, they are characterized by sinking of air and divergence conditions of air at ground surface. So ground surface divergence is there. So if you have ground surface divergence, you will definitely have convergence in the upper atmosphere. So you have opposite conditions in the ground surface and in upper atmosphere. If you have low pressure at the ground surface, you will have the high pressure in the upper atmosphere, leading to divergence of air. Besides that, if you have high pressure conditions at the ground surface, which are marked by divergence of air, you will have low pressure conditions in the upper atmosphere, which are marked by convergence of air. All these factors, the factors of high pressure and low pressure conditions on the ground surface as well as along the vertical dimensions, leads to the formation of jet streams. So generally, if you have convergence in the upper atmospheric regions, these regions are generally marked by ridges in the movement of upper atmospheric air currents. And contrary to this, if you have high pressure conditions in the upper atmosphere which are marked by divergence, they are associated with trough conditions or dipping of air currents in the upper tropospheric regions, leading to the formation of meandering patterns in the flow of jet streams or upper air currents. So where they dip, those areas are called as trough regions, and where they peak up, these areas are called as ridges in air current flow in the upper atmosphere. Somewhat wavy pattern is formed because of these fluctuations in the high pressure and low pressure conditions along the vertical dimensions extending from surface to the upper tropospheric level. Therefore, the jet streams become wavy in pattern, where they dip towards the lower latitudes in certain areas, as well as in certain areas they peak up towards the higher latitudes in certain areas. So the jet streams are primarily caused because of the variations and contrast in temperature and pressure conditions across the latitudes, even along the vertical dimensions till the tropopause. And such regions extend between 30 degrees north and 30 degrees south and 50 degrees north and south of equator. So between the tropics, there is maximum insolation which is received. Therefore, within the tropics, the temperature contrast is not that extreme. However, beyond the tropical areas, especially after 30 degree north till the polar areas, the temperature contrast in different seasons is very, very distinctive, which leads to very strong winds at the ground surface and even in the upper atmospheric regions. And as the differences in the temperature and pressure contrast increases with the winter solstice, the strength of the winds in the upper atmosphere also increases. Therefore, the jet streams are most well developed in these regions which are located along these latitudes in both the hemispheres. Also, these upper tropospheric wind circulation regions coincide with the boundary zones of three-cell air circulation, which is mentioned previously. So we have previously discussed in our last video that we have Hadley cell in the tropical areas, Ferrel cell in the mid-latitudinal areas, and polar cell of air circulation in the higher latitudes. So these jet streams attain permanent nature in certain areas around the world, specifically when they are located in the boundary zones of these circulation cells. For example, you have subtropical jet stream which is located between the Ferrel cell and Hadley cell. Similarly, you have polar jet stream which is located between the polar cell circulation as well as the Ferrel cell circulation. So two very distinctive permanent jet streams which are located in the upper troposphere are found along the boundary zones of the circulation cell. It can be Ferrel and Hadley cell, and it can be polar cell and Ferrel cell also in both the hemisphere. So you have polar jet stream between the polar cell and Ferrel cell, whereas you have the subtropical jet stream between the Ferrel cell and Hadley cell, because the boundary zones of these cells also have very distinctive temperature and pressure contrast conditions, which lead to the formation of the permanent jet streams which blow throughout the year along these boundary zones. However, with varying intensity, velocity, and even the varying latitudinal coverage in different time periods of the year. Now, coming to the properties of jet streams. The jet streams are characterized by the following properties. The jet streams are fast-flowing winds with average speed ranging from 129 to 225 kilometers, which are located in the upper tropospheric regions and blow at a height of 8 to 14 kilometers above the Earth's surface. They primarily blow from west to east in a circumpolar manner. What does circumpolar manner means? That is, their movement covers the entire globe. They are circumpolar in nature and encircles the entire planet, blowing from west to east. And they measure thousands of kilometers in length, whirling around the globe in a narrow belt of few hundred kilometers width and few kilometers of depth. They do not specifically blow in a single line, rather, they blow as rivers of rapidly flowing air currents in the upper atmosphere. Their circulation path or trajectory is wavy and meandering. Generally, their circulation is observed between the poles and it may extend to as low as 20-degree latitudes in both the hemispheres. The jet streams are developed both in the northern hemisphere as well as in the southern hemisphere. However, the southern hemisphere have more water surface as compared to northern hemisphere where you have more land surface. So because of contrasting nature of land and water surfaces and variation in their heating and cooling abilities, the temperature and pressure conditions are more contrasting and more extreme in the northern hemisphere as compared to the southern hemisphere, which has more area underwater, therefore more homogeneous conditions as compared to the northern hemisphere. Therefore, the northern hemisphere experience more developed, more strong and extensive jet stream formation, especially between the latitudes of 30° north and 60° north, primarily during the winter season. Besides this, the location of jet stream also shift throughout the year and they are said to follow the sun. As we have discussed earlier also that with the apparent northward and southward movement of the sun, the location, the dimension and the extent of jet streams also shift. So if you have winters in the northern hemisphere, the jet streams will be more extensively developed in the northern hemisphere. And if you have winters in the southern hemisphere, they will be more extensively developed in the southern hemisphere. Besides this, if you have summers in the northern hemisphere, then more land area is heated. And due to more heating of land area during the summer season, they shrink back towards the polar areas. Therefore, they are narrow and move poleward during the warm weather, while they broadens up and extend equatorwards during the cold weather conditions. And they may even extend till 20-degree latitude, extending from the polar areas in both the hemisphere during the winter season. Besides this, there is also seasonal change in the intensity of jet streams, wherein they become stronger during the winter season due to more prominent contrast in temperature and pressure conditions during the winter season and weakens during the summer season due to prevalence of more warm conditions in an area along the latitude. They have very high speed. They flow with very high speed. However, the speed sharply declines vertically and their high speed is limited to certain sections in the upper troposphere which extends between 7 to 14 kilometers. So it is not that the entire river or entire stream of jet stream blow with a very high intensity. There are certain sections in the central part of the jet streams where the velocity is very high of winds, but towards the peripheral ends, towards the outer margins, the velocity decreases. So the velocity is not uniform and decreases drastically on moving vertically downwards towards the Earth's surface, and the high velocity is concentrated mainly between the heights of 7 to 14 kilometers in the troposphere region above the ground surface. Now coming to the types of jet streams. On the basis of location aspect, jet streams are divided into 5 types. So as we have already discussed that different types of jet streams are found along different latitudinal extents in the upper tropospheric region. So between the polar cell and the peral cell, you have the polar jet stream. Okay. And then between the Ferrel cell and Hadley cell, you have the subtropical jet stream. Besides this, within the Hadley cell regions, you have tropical easterly jet stream. And one extensively developed jet stream is found in the polar areas, which is called as polar night jet stream. Besides this, you have several local jet streams also, which are found due to local variations in temperature and pressure conditions, such as the Somali jet stream. So most of the jet streams are found along the boundary zones of the tricellular meridional circulation between the polar cell, Ferrel cell and Hadley cell, as we have discussed in the earlier class. So now let's just see in detail what are all these different types of jet streams. Now, the first type of jet stream is polar front jet stream. As the name suggests, these types of jet streams are primarily found along the polar boundary zones, along the higher latitudes of the world, extending between 40 to 60 degree latitudes. And these particular areas are zones where the polar air coming from the polar areas continuously collides with the warm air which is coming from the tropical areas. So as the contrasting air masses collide, the polar air mass, because it is cold, dense, heavy, it has a tendency to subside below the warm air which is coming from the lower latitudes. And the warm air, because it is warm, lighter, it has the tendency to uplift. And continuously the polar air mass, which is dense, is pushing below the warm air mass, leading to the formation of extensive boundary zones which are called as fronts. And these fronts on surface are regions where you have very dynamic weather conditions. And above these frontal zones in the troposphere, you have the formation of polar jet streams or polar front jet streams. So they develop because of the steepened thermal gradient as the two contrasting air masses converge in these regions. And these jet streams blow in easterly direction and are primarily irregular in nature. So you can see in this particular diagram also that the polar jet stream exists between the polar cell and the Ferrel cell, and consequent convergence of two contrasting air masses lead to the formation of fronts. And these polar front jet streams are found in the upper tropospheric regions above 40 to 60 degree latitudes in both the hemisphere. And these jet streams are permanent in nature. They permanently blow in these regions. However, their intensity may reduce, their coverage also shrinks, and they are confined more towards the polar latitudes. The second type of jet stream is the subtropical westerly jet stream, and it is a belt of very strong upper level winds lying above the regions of subtropical high pressure belt towards the forward limit of Hadley cell, as we have discussed, primarily extending between 30 to 35 degree latitudes in both the hemispheres. Their circulation is primarily from west to east. So as you can see in the diagram, they are primarily formed between the Hadley cell and the Ferrel cell boundary zones in the upper atmospheric regions. However, since they are formed between the Ferrel cell and Hadley cell, they are fairly located in the lower latitude, extending between 30 to 35 degree latitudes. However, they are located at slightly higher elevation, primarily owing to the increase in height of tropopause at the lower latitudes due to more convection, due to more heating in the lower latitudes. So you can see in this diagram that the subtropical jet streams are located between the Weddell cell and Hadley cell, and their height is more than the polar jet streams because of more vertical dimension of the troposphere layer in the lower latitudes as compared to polar latitudes where the vertical dimension of troposphere is comparatively lesser due to less insolation and heating. So they are more or less regular. However, they intensify during the winter season, and they have profound impact on Indian subcontinent because these jet streams flow south of Himalayas for most of the time period of the year except summer. So they are responsible for winter rainfall in the northwestern parts of India, primarily during the winter season. Third type of jet stream is tropical easterly jet stream, and this jet stream particularly develops in the upper troposphere above the surface trade winds over India and Africa, primarily during the summer season, which starts somewhere around late June and ends nearly in September time period. So during this particular time period, when you have summers in the northern hemisphere, the sun is overhead the Tropic of Cancer. So this Tibetan Plateau region, which is a massive plateau region located north of Indian subcontinent, it gets heated tremendously. And as this Tibetan Plateau gets heated, it leads to the formation of low pressure center at the ground surface, and this particular low pressure center is characterized by convergence of winds at the ground surface. As you can see in the diagram also, that if you have convergence of winds at the ground surface due to low pressure central cold, you have opposite conditions in the upper atmosphere. So above the Tibetan Plateau in the upper atmosphere, you have high pressure center, and all the winds converge and ascend from this Tibetan Plateau region to upper tropospheric region, from where they diverge in opposite direction. So one wing ascends from this Tibetan Plateau, reaches the upper tropospheric level and diverges southward towards the East African coast. And this rapidly moving air current in the upper troposphere is called as tropical easterly jet stream because it is found along the eastern coast of Africa also. This particular jet stream, it sinks near the island of Madagascar due to high pressure conditions at the ground surface, and it pushes the southwest monsoon which enters Indian subcontinent during the July time period. So this tropical easterly jet stream is very important for their role in the mechanism of Indian monsoon. But they are seasonal in nature as compared to the polar jet stream or subtropical westerly jet stream. The tropical easterly jet stream is seasonal in nature and primarily develops during the summer time period due to intensive heating of the Tibetan Plateau and consequent convergence of winds at the ground surface and divergence of winds in the upper tropospheric region, leading to the formation of this tropical easterly jet stream along the eastern coast of Africa. Another type of jet stream is the polar night jet stream, and these jet streams prominently develop during the winter season around the polar regions extending beyond 70-degree latitudes in both the hemisphere. And as we know that the polar areas during the winter time period do not receive direct sunlight, because of which the temperature drops tremendously in these regions and intense cold conditions prevail, due to which steep pressure gradient exists between the lower latitudes and these polar areas, which is not only confined to the ground level but also the contrasting temperature and pressure conditions prevail in the upper atmospheric regions, and they even extend to stratosphere also in these areas. So these polar night jet streams, because of these steep pressure gradient, they blow in the upper atmospheric region in the stratosphere at the height of 30 kilometers approximately, due to which these polar night jet streams are also called as stratospheric subpolar jet streams. And when these rapidly flowing winds combined with the very dominant Coriolis force, which is very high in the polar areas, they race eastward at an altitude of about 30 to 40 kilometers and become strong westerly currents with very high wind velocity. And this wind velocity is immensely strong during the winter season, while the intensity of these polar night jet streams reduces during the summer season due to less contrasting pressure gradient conditions. And these polar night jet streams, they encircle the polar vortex, which is a region of intense cold conditions in the polar areas, wherein neither the warm air from the lower latitudes is able to penetrate, nor these areas receive direct sunlight during the winter time period, due to which these areas become intensively cold, and the cold conditions become more extreme during the nighttime period. So the intensity of these polar night jet streams also increases tremendously during the nighttime period in the winter season. So you can say that these polar night jet streams are upper atmospheric jet streams which are found in the stratosphere. The last type of jet streams are the local jet streams, which are confined to certain local areas, and they are greatly influenced by the local thermal and existing weather conditions in an area. So because of their limited aerial coverage, they influence the local weather conditions of the area, the precipitation, the wind conditions of a particular area where they blow. So one of the most prominently developed local jet stream is the Somalian jet stream, which is a low-level, fast-blowing jet stream which is found at the height of 1 to 1.5 kilometers along the eastern coast of Africa. So it is observed blowing from Madagascar northward towards the East African coast near Guinea, Ethiopia, and it reaches Somalia. And after reaching Somalia, somewhere around 9 degrees north, it exits Somalian coast and move towards the northeast direction towards the Arabian Sea region. And this particular local jet stream is very important for the southwest monsoon in India because it aids the progress of southwest monsoon in India. The onset of monsoon, the periodicity of monsoon, and also the variability and breaks in monsoon are highly influenced by this local Somalian jet stream. So local jet streams have local influence, and they define the precipitation conditions and wind direction, movement, influencing the local climate of any area. Now coming to the development cycle of jet stream, the period of transformation of the straight path of the jet stream into wavy and meandering path is called as index cycle of the jet stream. And the index cycle of the jet stream is divided into 4 stages which depict the progression of jet stream from almost straight stream of air to very extensively developed wavy and meandering air system. Starting with the first stage. In the first stage of the jet stream, it is positioned near the poles and it flows from west to east almost in a straight path. And the jet stream is bounded by the cold polar air in the north and warm westerlies towards the equator, and their path is almost straight. As you can see in this particular diagram also, that blowing from west to east, the jet stream maintains almost their straight path. The second stage of jet stream starts when the straight path becomes somewhat wavy. So with the increase in the amplitude of jet stream, the straight path gradually gets transformed into wave-like pattern. And in this stage, the pressure gradient is north to south. So it generally happens with the progression of winter season when there is steep pressure gradient between the northern polar regions, which becomes intensively cold as compared to the tropical areas which still remain warmer. So due to extreme north-south pressure gradient, the meanders begin to develop. The wave-like pattern start emerging in the jet stream, as you can see in this diagram, and the jet stream start extending towards the equator. So with the progression of winter season, the jet stream also become extensive and they start expanding towards the lower latitudes also, and their aerial coverage becomes much more pronounced. In the third stage of the jet stream develop into extensive meanders with very wide north to south extent, and these extensively developed meandering streams of air are also called as Rossby waves, and they extend towards the equator and position around 20-degree latitudes in both the hemisphere. So as the winter season progressive and becomes extreme, the jet streams which were earlier positioned near the polar areas now start extending towards the lower latitudes also. The pressure gradient shift from north-south to east-west in this case, which further intensifies the deep meanders in the jet streams. The displacement of tropical air mass to poles and polar air mass to tropical area can be seen. So as the wavy pattern of the jet stream emerges, you can see that there are deep ridges which are formed in the waves of the jet streams. While certain areas may experience ridges from where the warm tropical air pushes towards the colder regions, and besides ridges, you have troughs in the path of jet streams also, wherein the cold polar air mass pushes the cold tropical air mass towards the equator. And this intensifies these wave-like patterns into zones of anticyclonic and cyclonic grooves. So the anticyclonic grooves extend towards the poleward side of the jet stream, whereas the cyclonic grooves extend towards the equatorward side of the jet stream, resulting into extensively developed curved and meandering jet stream formation. The fourth stage of the jet stream is characterized by cutting of meanders of jet streams from the main path due to extensive meridional circulation. As the jet streams further intensifies and their north-south meridional extent increases, very deep grooves are formed along these meandering paths, and sometimes these grooves also cut the meanders, leading to development of various small branches emerging out of these jet streams circulating in different directions, and this result into independent cellular circulation patterns of cyclonic and anticyclonic conditions depending upon whether it's a low pressure system or it's a high pressure system. And these cellular circulation obstruct the general west to east circulation of jet stream. So as the jet streams become very extensive, small independent cellular activity starts in the ongoing very deep meandering wavy pattern which obstruct the west to east pattern of the jet stream, and the entire jet streams become highly dissected and grooved. And at this stage, the jet streams highly impact the anticyclonic conditions as well as the cyclonic conditions which exist on the Earth's surface. So these are the four stages of index cycle of jet streams. Now coming to how do jet streams affect weather? As we know that jet streams are not stationary phenomena, they are very, very dynamic as they keep on moving to higher or lower altitudes and even the latitudes, shifting in flow, braking or changing speed, all depending upon the seasons and other variable factors like solar radiation. So, depending upon all these factors, the jet streams are highly dynamic airflow systems. And as these jet streams shift, their shifting pattern can have significant impact on daily weather conditions, wind movement on surface, as the jet streams bring about horizontal convergence and divergence in the upper atmosphere. So they may intensify or they may also hinder the cyclonic and anticyclonic conditions on surface depending upon whether they are located upper air convergence zones or whether they are located in the upper air divergence zones. So as you have already discussed that if you have divergence in the upper atmospheric regions, they are marked by low pressure systems at the ground surface and they help in maintaining these low pressure system. Contrary to this, if you have convergence in the upper atmospheric regions, generally on surface you have high pressure conditions and these jet streams, they help in intensifying the high pressure conditions or anticyclonic systems or low pressure systems or cyclonic systems on surface depending upon whether they are located on areas of convergence or divergence in the upper atmosphere. Besides this, the position of jet stream above head can change the strength of an area of low pressure or high pressure at the ground surface. So if the wing of jet stream is directly located above the high pressure or low pressure system, the strength and the intensity of that existing high pressure or low pressure system may amplify. Also, the jet stream transport weather systems across the globe, influencing wind, precipitation, and temperature patterns across the latitudes. So if a system develops or move away from jet streams, the weather pattern may remain stagnant in that region. While the jet streams mainly transport weather systems from west to east, dips and rises in their path along a latitude may definitely lead to shift of extreme cold or extreme warm weather conditions north and south latitudinally also. So as we have discussed that there are meandering systems. If there is a dip, there may be anticyclonic conditions in any area, and if there is a ridge, there may be cyclonic conditions, gradually affecting the weather conditions latitudinally. Jet streams along the latitude may transport the cold conditions or warm conditions to north and south depending upon where the dip is or where the rise is. So their meandering path and position also greatly affect the weather conditions across latitudes. Jet streams definitely helps drive weather patterns around the northern half of the globe by pushing around storm systems into the region and intensifying them or pushing them outside the region or impeding their progress. So definitely depending upon the velocity of jet streams, the intensity of jet streams and their path and progression of jet streams, they may intensify any anticyclone or cyclonic system. Besides that, they may also hinder their progress. If the position and flow of jet stream coincide with cyclones, specifically temperate cyclones and their path, the intensity and ferocity of cyclone also increases. So they definitely impact the path, progress, intensity of cyclonic systems. It also immensely influences the local weather. While the position of jet streams do not automatically signify severe weather, its migration in strong frontal zones can bring harsh weather conditions. As the jet streams move north or south, the migration is associated with severe weather conditions, especially along the polar frontal zone. So a jet stream that dips to south bring cold air in winters, while the warmer conditions generally accompany a jet stream if it bulges towards the polar side. Therefore, the path, the direction, as well as the meandering pattern of the jet streams definitely affect weather conditions on a local scale, on a regional scale, and also can have impact at the global level in defining the overall climatic conditions along different latitudes. So regional influence of jet streams can be seen as it greatly influences the South Asian monsoonal regime, especially over the Indian subcontinent. We know that subtropical westerly jet stream, which is often denoted by western disturbances, causes rainfall in the northwest region of India during the winter time period. Besides this, the tropical jet stream influences the onset and variability of monsoons in the Indian subcontinent, and local jet streams like Somalian jet stream also influences the onset and progress of Indian monsoon. So jet stream may have a very wider impact, whereas it may regionally influence the weather conditions of an area. Although jet streams are primarily characterized by horizontal circulation, but due to strong vertical circulation, sometimes the jet streams are also responsible for transfer of anthropogenic pollutants due to rapid rate of mixing of air between the troposphere and the stratosphere. So as we know that we have two permanently blowing jet stream, that is the polar jet stream and subtropical westerly jet stream, which blows somewhere at the height of 8 to 14 kilometers in the troposphere. So somewhere here both these jet streams are active, and we have another jet stream which is called as the polar night jet stream, which blow at a height of somewhere around 30 kilometers above the Earth's surface. Because the jet streams prominently travel in the boundary zones of stratosphere and troposphere along the tropopause layer, and they are also characterized by vertical movement of air. This sometimes lead to the transfer and transport of anthropogenic pollutants to the stratosphere layer, like the chlorofluorocarbons, which can be very detrimental, and even the latitudes which are not even producing the anthropogenic pollutants, even in those regions, these pollutants are transferred. So they generally sometimes lead to long-range transport of aerosols from the lower latitudinal areas to the polar areas. And even in the polar areas, the transportation of the anthropogenic pollutants reaches the higher atmospheric level in the stratosphere. And in the past, we have seen the detrimental effects of the transfer of anthropogenic pollutants to stratosphere in terms of depletion of ozone layer. So jet streams can definitely affect weather conditions by the transport of anthropogenic pollutants also to the upper atmosphere. Satellite-like geostationary operational environmental satellites (series) help meteorologists and other scientists to detect a jet stream's location by using infrared radiation to detect water vapor in the atmosphere. And tracking the trajectory direction of jet stream helps meteorologists to figure out where the weather systems can progress next. And it is very useful in weather monitoring, weather forecast. So just by tracking the trajectory and direction of a jet stream, meteorologists can predict where the weather system is heading ahead. And it definitely helps in the weather forecasting and monitoring, specifically in the middle and higher latitudes of the world where the jet stream systems are very extensively developed. Now, beside the impact of jet stream on weather condition, jet streams also impact the aviation conditions. Jet streams are helpful in the air travel. Although the position and height of the jet stream changes seasonally, it essentially moves around at a similar level to that of where the general airliners fly from around 20,000 feet above the surface of Earth to 40,000 feet. So the direction and the velocity of jet stream definitely impact the aviation conditions. Flying along the flow of the jet stream is quicker and save fuels, as the strong winds of the jet stream can help push the aircraft, providing much needed boost of speed for aircraft traveling from west to east, cutting down the travel time. So if the aircraft is flying in the direction of jet stream, definitely the fuel saves, the time saves, and the air travel is much more quicker. However, flying in opposite direction to the jet stream can delay the flight time and is expensive on fuel also. So if you are traveling from west to east in the jet stream belt, it will provide boost of speed to the aircraft, saving time and resources. Whereas if you are traveling from east to west, you will be traveling against the jet streams, which will lead to delay in flights and more usage of fuel will take place. Jet stream can also get bumpy, especially where the wind changes its speed and there is sudden changes in the temperature and pressure condition. There is sudden steep pressure gradient in the atmosphere, or where the stream isn't straight. This churns up the air, causing turbulence during the air travel. So it can also hinder the air travel experience, and it can churn up the air, leading to turbulence during the air travel. So from a technical perspective, flying on the side of the jet stream where there is cold air, it makes the aircraft engine operate and burn fuel more efficiently. Jet streams definitely impact the aviation conditions if you are located in those specific latitudes where the jet streams are most well developed. Coming to the summary of the video lecture, jet streams are swirling bands of air that flow high overhead and causes changes in wind and pressure at that level. This affects the weather conditions near the surface, such as areas of high and low pressure, and therefore helps shape the weather in different latitudes of the world. So these rapidly moving circumpolar streams of air located at an average height of 8 to 14 kilometers affect the wind and pressure conditions on ground also. Jet streams result from the interaction between complex atmospheric processes like development of high pressure and low pressure systems, warm and cold air, frontal circulation, Earth's rotation, temperature variation, seasonal changes, etc. And the period of transformation of straight path of jet stream into wavy and meandering path is called as the index cycle of jet stream, which has 4 stages, and these 4 stages depict the progressive development of jet stream from moving in a straight line to extensively developed, dissected and curved meandering wind system with extensive north and south dimensions, and these extensively developed wavy jet streams are also called as Rossby waves. So on the basis of location aspect, the jet streams are divided into 5 types. So you have polar front jet streams, which are found in the polar areas, and you have subtropical westerly jet streams, which are found in the mid-latitudinal areas more towards the polar end of the Hadley cell. And then you have tropical easterly jet stream, which are found in the tropical areas during the summer season. And you have polar night jet streams, which are found during the extreme winter along the polar latitudes. And finally, the 5th type is the local jet streams, which are developed mainly due to the local topographical, geographical and climatic conditions, and their area of influence is also limited. The jet streams may intensify the cyclonic and anticyclonic activity on surface depending upon their movement path, position and velocity, and how and when they coincide with the ongoing surface wind systems. ongoing cyclonic and anticyclonic activity. And jet streams also help transport weather systems across the globe, influencing wind, precipitation, and temperature patterns. They are also significant for aviation purposes. They aid the flights which move from west to east in their zone of influence, whereas they hinder the path of flights which move from east to west in their zone of influence. And finally, tracking the path of jet streams and tracking their movement is crucial for weather forecasting and monitoring purposes because they help in predicting the weather conditions which may prevail in an area. And therefore, the jet streams help in defining the overall climatic conditions of an area on Earth. So this was all about jet streams. I hope the video was informative. Thank you so much.